Hello, this is Eric Lee, and this is my fourth video. I've been saying that I was going to explain why there's a cosmic speed limit to the speed of light. And in Einstein's equation, E equals mc squared, basically he said that the faster an object will travel, especially near the speed of light, the mass would increase, and basically you would most likely drop out of the existence of our space and time. Now, why would this happen? I've watched countless documentaries on the subject, and there seems to be no real explanation except they just go to the equation, and they don't explain the exact details of what could be happening. So I'm going to attempt to try to explain why Einstein predicted that would happen. And in my previous videos, I said that there was a particle as yet undetected by the Hadron Collider, and physicists admit that there are particles that are passing through our body in the hundreds of billions, and we are not affected by it at all. And through the Isaac Newton's formula of the force of gravity, F equals ma, which is a force of gravity is equal to mass times acceleration. These very particles that I described in my previous videos, they seem to be attracted to mass, and they do obey gravity, and they are gravity itself. Because I asked the question, well, if the general theory of relativity is the distortion of space and time, well, what is space made out of? What is it distorting? And that's where I said there has to be an unseen particle that is surrounding these massive bodies. And I went through the whole explanation of that, so I don't want to keep rehashing the idea to be so redundant. But anyway, let's get to why a spaceship, which I'll draw here. It's just a simple rocket, and let's say it's got these crazy gigantic engines that are driven by the force of a small star, because that's what you would need. You would need massive quantities of energy to start even beginning to approach the speed of light. So the first thing is when you accelerate and you start traveling at the speed of light, if indeed there was a medium that it's traveling through, you would start to hit resistance, and it would be all these particles that are in the way. And that's much like when Chuck Yeager, who was the first man to break the sound barrier, he flew his I think it was the Bell X-1, if I'm not mistaken. He approached the sound barrier, and he broke through it. But before he broke through it, he found that all the controls did not work at all on the airplane, and it was some crazy forces of the air passing over the wings and the entire aircraft that caused this phenomenon. I'm not going to get into all the aspects of that, but basically, it's a barrier is what I'm saying. And what would happen in this interesting situation is that we, as I've said before, we live in the sea of particles. These particles, hundreds of billions and billions and billions. I sound like Carl Sagan when I say that, but it's billions of these particles all throughout the fabric of space. It makes the fabric of space, actually. And what would happen is, first of all, the reason why the mass would increase would be, first of all, this spaceship. You must understand the force that is being exerted by the engines would start traveling actually a little bit faster than the vessel itself in the front, and you would have like this entire vessel starting to collapse in on itself, much sort of like a mini star, you might say. You know how fusion begins, and yeah, that's what would exactly start to happen. This vessel, this starship, would start colliding into these particles, and it would grow in mass because these particles are attracted to mass, and not only that, the resistance would cause this whole entire vessel to start to turn into basically a ball of energy, because it would just start to fuse together from the sheer force of the rocket engines, and it would just crinkle up the whole thing into just this big ball. It would just start condensing into a ball, and then these particles would basically surround it, and it would turn into basically a black hole. It would just drop out of our space and time as we know it. And that's the simplest way that I can explain that. Maybe it's not a black hole if it doesn't turn into a black hole. Maybe, what does that matter? It's like 1 teaspoon. Carl Sagan said a teaspoon of, was it a quasar or a pulsar? He said that if you took like a tablespoon or a teaspoon of this substance and you dropped it onto your floor of any surface of the earth, it would fall straight to the earth. It would become so dense and heavy. And anyway, that's kind of what would happen. You would just have this condensed mass so fused together and massive, it would just fall out of our reality. And so what is the proof that there could be this string-like matter? I call it Keku matter after Dr. Michio Keku, who's the biggest proponent of string theory at the time. And I just came up with this random name, but you could call it anything you like. I'm not exactly sure. And physicists, as I said, that work with the Hadron Collider, they said there's yet smaller particles to be detected. And there's other things that I wanted to point out with this theory of mine, and it's this interesting theorem. It's called it's just called Bell's theorem, and it deals with light photon waves. And initially I thought, like, when you spoke about light photons, that they were just like these rays of energy, and that they were like the photon was shaped like kind of like this thing like that, and it contained this packet of energy, and that it was the ray of light that would enter our eyes and will reflect off of objects. But actually, light travels in waves. It just travels in these weird waves, and that I find very telling, in a sense that if you're creating waves, well, then there must be a sea of particles for it to create a wave pattern. So that's one thing. And then the person that was explaining Bell's theorem, he said another thing that was very extremely interesting, and he said that basically for Bell's theorem, John Bell actually predicted quantum entanglement would occur between the photons of light. And except the person explaining this mathematically said that quantum entanglement of photons wouldn't necessarily work, because you would have to have these entangled particles travel faster than the speed of light. Well, if you look at, I think I put it on my Pinterest site actually. I love Pinterest, and it's so interesting. I said that there's one thing that's faster than the speed of light, only one thing, and that's time, and or the lack of time. And as soon as he said that, it just clicked into my head that basically, well, there's your anomaly right there, because not only did Bell say that this phenomenon between light photon waves would require entanglement of photons, light photons. This very smart, brilliant person explaining Bell's theorem, and why it depends on this thing called locality, and all this very complicated mathematics pertaining to the whole theorem, how it works. But anyway, hold on one second. So yeah, sorry about that. I just kind of lost my train of thought and had to regather my brain cells. But basically, for what he said was, this person explaining Bell's theorem again. I'm so sorry. I keep getting so redundant. This quantum entanglement to be faster than the speed of light. Well, it's possible, and if you could think of a multiverse where time just doesn't exist, and as I explained in my previous videos, for time to exist, you have to have a frequency or vibration of all the matter in the universe. They don't all have to be at the same frequency, but they all have to be in a state of what they call entropy. And basically, our universe is vibrating or shaking, you could say, at a quantum level into disorder. And I guess this could be a subject for my ultimate goal, which is to explain time. But basically, if you had a universe, which I believe that the Big Bang was just a part of the cycle where the very basic particles that form our universe, or the Keiku, like string-like particles, they fell into, or they came into existence in this universe that was full of these particles that exist in a multiverse that has no time. And it's just potential energy. And basically, information is transmitted at a scale that we can't comprehend. It's if you have a multiverse that has no existence of time, then it would just be an instant for information to travel between the particles that exist in it, because there would be no time. And I could explain how that would be possible to have a multiverse with no time, and in another video, because this one's getting pretty long. But anyway, I'll finish it at this point right now. I'll make a maybe part 2 to this. It's a little complicated. I thought I could get further and not take too much time. My family members are like, your videos are gonna be like an hour long to explain your entire idea. But I'm just trying to give pieces of what's going through my crazy head, and hopefully I'm making some sense to what I'm saying. And I'll finish the video at this point and make another one to try and explain what happened at the time of the Big Bang, and why there is only 3 multiverses in this equation, which is the originating multiverse of where our particles came from, then our physical Big Bang universe where it all came into being, and then the underlying particles that exist, that this whole universe is filled with, and we are actually just spreading out into, or popping out into, in a sense, because these elementary particles are being converted into gases that are becoming the stars themselves, and matter itself. So basically, you kind of get what I'm saying. So hopefully you do. I'm sure you do. So thank you for listening to this ramblings of mine, and I'll make another video pretty soon. These are kind of difficult to make for me because, like I said, I just do it right off the top of my head. I don't have too much notes I mean, I've got some today because it was a little, but I didn't get to cover all the different aspects of what I wanted to cover. It's already going on 19 minutes. So I'll say goodbye, and keep your sense of humor, and thank you very much for listening.